This video corresponds to application exercise 4, and you'll probably find it a great deal of help as you're working through lab 2. We're going to talk about the grammar of data wrangling. The folks who developed the tidyverse seem to have a pretty good sense of humor. They like playing with words, I think. And the first time I heard about data wrangling was from Hadley Wickham, the author of the main book that we're using. So wrangling, the definition that I believe they were referring to, is taken from a noun meaning controlling animals. So commonly used in Western United States and Canada, but defined as the activity of taking care of or moving animals, especially large animals such as cows or horses. It's a lot of work, and it can take a little bit of strategy. And we're going to be treating our data as we would treat cattle if we were wearing a cowboy hat. Yippee-ki-yay. So, if you've used R before the tidyverse, you will have heard of data frames. And data frames, at their basic, you can think of them as a table that stores data. And tables are an extension of data frames created by uh, the tidyverse people. And these are the main differences between a tibble and a data frame. If you're working di- in the tidyverse, most often you'll be working with a tibble instead of a data frame. Hadley Wickham describes a tibble as being an opinionated version of the R data frame, and the tidyverse people do have some very specific opinions on how data should be written, how data should be handled, and how code should be written. Tibbles are a kind of data frame, and there are two main differences between a tibble and a data frame. It relates to printing and subsetting. I've given you a link that you can look at if you care about the deep down dirty details. But for us, the one of the big things is that Tibbles handle printing much nicer than data frames do. Uh, if you have 337,000 rows, you probably don't want to see the entire Tibble printed out every time you type its name. If you print a data frame, it will print all of the rows in your data frame, or your R program will die because your computer doesn't have enough resources. So for the printing purposes alone, I prefer the Tibble. I try to use it as often as I can. And if you're using the tidyverse, it's what happens by default. There's some talk in the in these slides about stricter subsetting. I'm not going to worry about that. Okay, so we're going to demonstrate data wrangling using a data frame or a tibble in the NYC Flights 13 R package. This data set includes characteristics of all flights departing from New York City airports, John F. Kennedy, LaGuardia, and Newark International in 2013. So we'll load the libraries up with the two functions that you see below. Oh, before I go further, I'm going to probably be using the word tibble and data frame and data set interchangeably. For the purposes of this presentation, when I say data set or data frame from now on, I'll be referring to a tibble. Okay, so we can take a quick look at some of the things related to this flights database. There's a function called nrow that we can use to find the number of rows in a tibble. So as we mentioned before, there's about 337,000 flights that are tracked from these New York City airports. There's 19 columns or 19 variables in this tibble. They represent just different attributes of the flights. If you want to take a look at what all of these different variables mean, you can write question mark flights with no space, and the help function of R will show you the definition of the items in this database. Okay, there are some useful functions in the tidyverse that help you take a look at data as an exploratory in an exploratory manner. Glimpse is one that I like a lot. It gives you the number of rows, number of columns, names of all of the variables, and the first few observations of each of the variables in the tibble. You can view it as being a transpose of the tibble uh, where the columns become rows and the rows become columns. Another thing that you can do to get a feel for your database as you're starting out is just take a look at the names, and the function names just returns the names of each of the columns. These numbers are helpful for locating things. So distance is the 16th column, hour is the 17th column, minute is the 18th column, and time underscore hour is the 19th column. Take a look at the head of the date of the tibble. You'll see the first six variables shown here. Sorry, you'll see the first six rows of the flights tibble shown here. And it indicates there are 19 variables. This is only showing the first 9, and this is indicating that there's 10 more variables that aren't being shown. Okay, let's get into some data wrangling with dplyr, yippee again. And dplyr is the main package that's used in the tidyverse for data wrangling. There's full documentation of it at this website. And one of the things that the tidyverse people do is provide cheat sheets for most of their packages, or yeah, most of their packages. And we'll take a click on this to get a quick look at that. There's a nice description of most of the things that you can do to transform data with dplyr here. On the right-hand side here, and this is also duplicated on the computing resources part of our website, is a PDF that gives a really nice, concise summary of the different functions. This is probably most useful once you've got some familiarity with what's happening, but I find it to be an extremely good reference to keep around. In fact, I found it so good that I decided to print it off in color and laminate it as one page as a reference. So you may find it useful as well. Hey, here's a few of the row operations that you can do in dplyr. You can use the slice function to choose rows based on the location. So basically location defined as row number. You can choose rows based on values in the columns using the filter function. You can change the order of the way the rows are in the tibble with the arrange function. I commonly use an ascending sort or a descending sort. And if you want to take a look at a smaller subset of your tibble, sometimes it's useful to take a sample of it. So if we said sample underscore n 100, we would randomly pick 100 of those 337,000 rows in flights and work with those for work with those that subset. So this is a demonstration on how you can use slice to take the first 5 rows of flights. This is part of the one of the things labeled demo in the application exercise, so you can duplicate this. So what we're doing is taking the flights tibble, we're piping it to the function called slice 1:5, which means take the flights tibble and then take a look at the first 5 rows the uh, of the tibble. Here's an example of filter. What we want to look for is filter for flights to the Raleigh-Durham area. Uh, this is coded with the airport code RDU. And the reason why we're using RDU here is because RDU is in North Carolina and so is Duke University. So what we're doing is taking the flight's tibble and filtering it so that we're only seeing the flights where the destination is RDU. Note the double equal sign for logical operator is equal to. It is different than the single equal to sign, which is an assignment operator. Okay, a little bit more explanation about the pipe. So the pipe is an operator for passing information from one process to another. You may see in some older code or older videos that the pipe operator was written as percent greater than percent. For our purposes, we're going to treat them as equivalent. They're not exactly equivalent, but for our purposes, they're close enough. And this pipe operator is used mainly in data pipelines to pass the output of the previous line of code as the first input of the next line of code. When you see code with the pipe operator in, you can read it as and then whenever you see the pipe operator. Okay, so what we're trying to do with this chunk of stuff is to find out which airline is most delayed on average in getting to RDU from a New York City airport. So our goal is a tibble that looks like this: 5 rows, 2 columns, with the rows sorted by mean arrival delay in minutes, and the first column showing us the airline code. If you use question mark flights to look at the data definition for the flights database, you'll see a way of finding out what the airline codes, 2-letter airline codes, correspond to. I know that UA refers to United Airlines. I'm not sure what the other 4 refer to. Okay, we start with the flights data frame, and here is the way the flights data frame looks. If you just type in the name of the tibble or data frame, what it'll do is print out that tibble. And because this is a tibble, it's only showing the first 10 rows when we print it out. So there's the first 9 columns and the first 10 rows of the flights data frame. If we pipe that to a filter argument and we specify the dest equal RDU, or the destination being equal to the code corresponding to Raleigh-Durham, we reduce the number of our tibbles or of our rows in the tibble quite considerably. We're down to about 8,000 flights now. So we can read that as take the flights tibble, then filter it so that the destination is Raleigh-Durham. Then we're going to group it by carrier, which means uh, we're going to use carrier to group the data that we're looking at. We're going to summarize each of those groups, and we're going to create a variable called mean underscore r underscore delay, which we calculate as the mean of the AR underscore delay, or the arrival delay time in minutes from the initial tibble. And we've got this extra bit here that says na.rm equals true. It's possible that there's some data in the original tibble that does not have a code for the arrival delay. In other words, it's coded as NA. So what this does is calculates the mean arrival delay, excluding the NAs or missing values. Then we can arrange it in descending order of our new variable, the mean array delay. So this gets us to where we want it to be. We've got the tibble sorted by descending arrival delay, which is different than it was before we sorted it. So we can see from this that the United Airlines has the longest arrival delay, mean arrival delay in minutes. There's a number of column operations that we can do in the tidyverse. One of them is select, and that we use that to pick which columns are included or not in our subsequent operations. If we want to change the names of columns, we can rename them. And if we want to change the values in a column or create new columns, we can use the mutate function or operation. So we can do some summarizing based on counting variables. So we can count unique values of one or more variables using the count operator. If we want to do the summarize function, we'll probably want to do a group by first. So group by allows us to perform calculations separately for each value of a variable or each unique combination of a number of variables. And summarizes allows us to collapse a group into a single row. So we'll see how that's used. Oh, actually, we did see that in the previous slide where we calculated the mean arrival delay. So you've got enough information now to go to the application exercise. Most of the bits that I've labeled demo in the application exercise have been covered in this video. Uh, what you want to do is to accept the invitation to open the application exercise as follows. So again, we're using a GitHub repository to store the data. We're going to create a new project in RStudio on Posit Cloud, and you can work through the application exercise. Before I let you go, let's do a recap on the pipe operator. So what the pipe operator does is passes what comes in before it into the function that comes after it as a first argument in that function. So the sum function takes uh, two or more operators and calculates the sum of those operators. So it would return the value of 3. Another way of doing the same thing would be to take the 1 and pipe it to sum with 2 in the function. This has the effect of taking this 1 and putting it in front of the 2, so adding the first operator to it. So 1 piped to sum 2 is exactly equivalent to sum 1 comma 2. They both return 3. As far as formatting your code goes, always use a line break after the pipe and indent the next line of code. This allows us to more easily read what we're doing. It allows us to do things one step at a time, like we were doing in words back in this slide. Okay, so logical operators. You can see these are also in the application exercise, but we've got an operator that is used to determine if the object on the left-hand side of the operator is less than the object on the right-hand side of the operator. We've got something corresponding to less than or equal to, something corresponding to greater than or equal to, or exactly equal to, and also one corresponding not equal to, which is indicated by the exclamation point. Not is indicated by the exclamation point. We've got logical operators for and, so is the ampersand is used to indicate and. This is a mistake. The or logical or operator is just this vertical bar, so it's used to indicate X or Y. This operator is.na is used to determine if the value of X is NA or not available for that particular observation or row. If we're looking for is not NA, we preface this with the exclamation point. Uh, you can see if X is in something. So let's just pretend Y is a vector of, let's say, 2, 3, and 4. If we said 3 in 4, it would return the value of true. Sorry, 3 in Y, it would return the value of true. Similarly, not X in Y would be just the complement of that. And in more general, you can use this not operator like this. Not something, so it's just something that'll return true if something is not equal to X. For example, not X in Y, or not X less than or equal less than Y, and so on. So I will turn you loose on the data wrangling application exercise, and I will correct this in the slides. Okay, thank you.